All right. Hi, Lorenzo. Nice to see you.
Hi Dan, nice to see you again.
I um, I was thinking about the first time we met. I was a number of years ago at IETF meetings. It's when you guys were first getting started, actually, with Meetecho or Meetecho, I guess, if I try to do a little bit better pronunciation there. Um, so, maybe you could just talk a little bit about that. Sort of like, what is your background? Because people know you as an expert now because of the work that you've done, but they may not realize how you got started and that a lot of this has happened pretty quickly in the last few years.
No, yeah, it did. I mean, the ITF actually was an excellent playground for my activities at the time, especially when I was trying to grow up as an implementer, as a researcher, and things like this. And it may sound weird, but I actually have been in the ITF for quite a long time, if I think about it. So it's been more than 10 years now. And it all started with my master thesis, actually. So when I wanted to start my thesis, at the time, I didn't even know much about networking, VoIP, and so on. So I was familiar with it, but I had never actually tinkered with it much. So I had done an exam on network computing, but that was pretty much about it. And then when it came to do my master thesis, I started checking what I might do. And eventually I ended up in the network computing department, and this is how I ended up meeting Simon Romano, who you
Right.
also know, and another professor, Alfonso Buono, who basically showed up magically talking about this idea of a thesis working on voice over IP, over asterisk, and nice cool things that could be done.
Ah,
And it really blew my mind away. And this is how it all started. And my thesis actually involved the ITF from the very beginning, because the idea was to start interacting with the ITF community, especially in the XCon working group. So the XCon working group
right.
was quite big at the time. It was on centralized conferencing, and we wanted to play a bit around that. So using the new protocols that they were starting to work with,
Hmm.
play with Stardust conferencing and so on. And my thesis was exactly on that, basically implementing the BFCP, the binary flow control protocol, and trying to integrate it in existing frameworks, see how it works, and so on. And in fact, my first ITF ever was shortly after I did get my master degree. So as soon as I got my degree, I flew to San Diego for my first ITF ever. We did a demo there, and I mean it. It was all new to me, we did get a very good response. And since then, I've basically attended almost all the ITF meetings. I think always with the same idea and spirit in mind. So trying to participate in the ITF, trying to prototype the new protocols in the true spirit of the ITF, which is rough consensus running code. So we were
Right.
really interested in the running code part,
Right. You
and
wanted to
we did
build.
work a lot.
You
Yeah,
really,
exactly.
right. Yeah.
So and this is how it all started, and since then I never stopped. So I was also very active in the media control working group, which was another
Right.
effort that I was really interested in. And I think this may be one of the first times that we actually interacted with you specifically, because you were involved in voice XML or something like this at the time. So this was partly related to what media control was trying to do. And that period really made me grow, both as an ITF contributor, as an implementer, as a researcher, everything, because I was keeping on working at the university after my thesis as a junior researcher, trying to do research, trying to build new things, and so on. And which eventually is also what led to Meetecho being born, and what I am today.
Okay. Cool. Yeah, that's right. Wow, I'd forgotten it was that long ago. That was back from in the MRCP days, which was part of the work with Voice XML that we
Yeah.
were doing.
Yeah,
So,
media control was basically a way to try and standardize the same things, but using SIP as a protocol, and the control channel that they could use to orchestrate whatever needed to happen on those channels.
yeah, that makes a lot of sense. And yes, WebRTC is kind of the spiritual successor to SIP, really. There's a
Yeah,
lot that we learn from SIP, right? So,
yeah, and I did take a lot of lessons from there actually, because the media control specification is something that I really loved at the time. I loved working on it. We prototyped it and so on, and a lot of the things that I learned during that process I ended up putting in Janus itself. So it may come up during the presentation anyway, but this is something that really stuck with me, and a lot of the things that ended up in Janus, the modular architecture, the way that you can have different plugins using their own protocol to interact with the application and so on, are all things that I actually derived from that lesson. So really anything that I did at the ITF really helped me grow up.
Okay. Cool. Actually, I'm glad you mentioned Janus because that's one of the main things I wanted to talk with you about today. I'm going to ask you a question. I've done a number of interviews, of course, and with people, and I think this is the first time I'm going to ask that if there's a way you could explain Janus and like pretend that I'm completely an idiot. Just because Janus is. Janus does some really cool things, and the way it's structured is nice in certain ways. Okay, but I think it might be helpful to start off trying to explain it in as sort of brain dead a way as possible before we get into the normal explanations you would give to someone who's been working in this area for a while.
Yeah. So maybe the easiest way to explain it is let's say start from why we actually started working on it. So basically the idea that we had at the time. So I mean, we've been providing a conferencing service. We were providing a conferencing service for a long time. So we had a web conferencing platform, mostly born from the efforts that I was describing before. So the university effort, all the prototyping that we were doing within the ITF and so on. So this all ended up contributing to a whole conferencing application that we were implementing. And so as soon as WebRTC saw the light, we tried to take advantage of this and make sure that you could also use WebRTC to access exactly the same features as you could do via SIP, for instance. And this was, of course, a bit of a not always an easy process because, of course, we were using some existing open source application for this, but and so some were already WebRTC compliant, some were, let's say, on the right way, but not exactly compliant, and so on. So we worked a lot to make those work and trying to put everything together, basically. Eventually, we ended up in a place where there are actually things that we wanted to do with WebRTC that we couldn't, if not via heavy tinkering of those platforms and so on. So we were basically too much constrained by applications that were too vertical for our own needs. And so basically, I think about 4 years ago after the summer, I started tinkering a bit with the WebRTC specification myself. So starting actually to study much more the code than I had done before. So studying exactly how ICE worked, how DTLS worked, all those things. And trying to build a small WebRTC stack bit by bit, brick after brick. And so trying to get ICE to work after that, trying to get DTLS and SRTP to work, and then checking what happened if I started sending my own RTP packets and whatever happened with the browser and so on. And it seemed to work much better than I expected, actually. And this is actually when we got the realization that as soon as you have this kind of functionality available, then you can pretty much do anything you want with it. So as soon as you have a WebRTC stack ready, then there's no limit with whatever you can do with the packets that you receive and with the packets that you actually may want to send. And this is how we came up with the idea of Janus itself. So a component that implements all the WebRTC functionality in the core. So it takes care of creating a peer connection for you. And then what you want to do with the actual packets, so whatever the browser sends you or whatever you may want to send to the browser's back, is actually up to a customizable logic that sits in different plugins. So you may have a module which you might see as an application that sits within Janus. This module I may decide to just send you the media back exactly as it is, and this could act as an echo test module, an echo test plugin. You may have another plugin that acts as a SIP gateway, another application that implements an SFU and whatever else. And basically, the idea was to have something that was as modular as possible, so that if we came up with additional and different ways of handling the media that were not available previously, you could just implement your own stuff and implemented it in a new plugin. And this is where the media control specification really did help me a lot, because this was at the basis of media control itself. So just to give a very quick summary, just to give an idea to whoever is listening to this. The idea was that you might have a SIP call that would end up to the media server, and then you had an application server that would actually control what needed to happen with this SIP call. So you may decide to start an IVR, you may decide to play an announcement, you may attach this SIP call to a conference and so on, all in a really dynamic fashion. So all the application server needed to do was handling incoming SIP calls, forward them to a media server, and then use a control channel to decide whatever needed to happen. So again, play with IVR or mixer functionality on things like this, which was a really flexible approach. And media control was itself based on the concept of control packages. So each of these functionality were actually conceived as different modules themselves. So you might have the IVR module that implemented all the IVR functionality. The mixer functionality would implement all the kind of application or bridging, mixing, bridging features and so on. And you could combine them in order to do cool things on that SIP call. And all of those things, actually, I brought with me, and I tried to bring as much as possible in Janus as a concept, which is why we ended up with this kind of modular approach where each of the plugins can actually also talk its own language, so that if you talk to the SFU, you can actually exchange a conversation from a signaling perspective with the SFU itself, with the Janus API only acting as a transport for that, which gives you a certain flexibility also in terms of how you can implement new plugins, new stuff, and new things out of this approach. So I don't know if this is an easy enough explanation of how Janus works and what it is, or if you want me to give you any more details about that.
I think it is, but I think sort of the question that comes to my mind is, when if you were to try to compare yourself to other solutions that are out there. I mean, you described a little bit about why you went this direction, but it almost sounds like you just didn't like the way anybody else built it, because it didn't seem to quite do what you needed, and so you built your own. So now, looking today, if you were to compare, why, it's funny, I was actually trying to figure out who to compare the Janus gateway to, and that's kind of the problem, right? Because I guess other gateways that are out there maybe existed before WebRTC, and so they added stuff on to make it work with WebRTC, or you have a purely JavaScript application that runs in your browser, but that's not really a server. You can fake it and make it a server, but it isn't really. It's an application running in a web browser. So I guess maybe I'm answering the question, myself. And do you want to add on to that? Sort of where do you fit? I think from a taxonomy perspective, you're a gateway, but you're a gateway that can do essentially anything that WebRTC can enable.
Yeah. In fact, we've been asking ourselves the same questions. At the time we published Janus, we actually released it as the Janus WebRTC gateway, which actually, funnily enough, ended up confusing people about the purpose of Janus itself, because as you mentioned, many people are actually convinced that Janus was actually just a gateway and stuff like this one. You could actually do many more things with it. So we started engaging the community and ask them, what do you think we should call Janus? How do you think we should define it? So should it be a WebRTC server, an application server of some sort? Is it a WebRTC enabler? What exactly is this? And I really cannot give you an answer by itself. If not, maybe the most generic definition may be a WebRTC enabler, a WebRTC server of some sort, because it allows you, as you said, it allows you to act as a gateway because it can interact with legacy technologies like SIP, RTSP, or others. Depending, you can also write your own application to interact with something that we didn't even think up to this very moment. Or you may actually just live within the WebRTC world by itself, and so you can use the SFU without ever leaving the WebRTC world, for instance, if not, let's say, to forward those streams outside in order to do other stuff with it if you wanted. But in general, yeah, the idea is that we didn't want to put any boundary on what we might do with WebRTC itself, because WebRTC is by itself a very interesting technology that actually enables you to do very interesting things. So it is in part, let's say, the heir to all the SIP world, the SIP infrastructure, and so on, but it should be constrained to just that, because it would mean limit the WebRTC specification to also the context of a specific session like SIP tried to define, to the applications that they try to confine the SIP specification to. which shouldn't happen with WebRTC. WebRTC is just a technology that allows you to do a lot of crazy things together. And this is what we tried to do with Janus itself. So, and I mean, at the time, before Janus actually existed, we did manage to do cool things with WebRTC as well, and we were actually very happy with how those applications performed. So Asterisk is a very interesting tool that we still use to this day, and the conferencing application that we were using at the time as an SFU, which is now called LeeCode, was actually a very interesting component that we also contributed to and so on. But they were just, let's say, too focused and too vertical for our own needs. So they did their job very well, but it was really hard to try and bend them to actually what were our own needs. So one of the use cases that we had in mind, and we still have in mind to this day, was large-scale broadcasting. So the idea that you can do, let's say, the main use case would be, let's say, let's just stream the Super Bowl out in the world, and let's do it with WebRTC because it's what gives you the lowest latency available, and sports people are always angry whenever you get something that is working seconds later and stuff.
Sure.
Yeah, exactly. The idea is this possible? And the quick answer and the ideal answer would be yes, you could do it with WebRTC, and of course it's much harder. The actual answer is much harder than that. But you do need some kind of a WebRTC enabler to do these things. So if you want to inject media with WebRTC, then distribute it in a network that is not WebRTC compliant, and then turn it into something that is WebRTC again, or something like mind 4 years ago, we still have it on our mind today. So we're trying to work on cool things like this, and to actually be able to do all of those things, we needed to have much more control over the WebRTC stack and on all of the process that involved the transition from the WebRTC world to something else and vice versa. And whether this something else actually means that you do stay within the WebRTC world as the SFU, then this is an added value. But in principle, the idea is that we didn't want to actually put any boundaries on what we might do with those packets. So we wanted to be able to handle those packets. And in order to do that, we needed to have complete control over the process, better understanding of the WebRTC specification, which is one of the things I'm grateful for Janus, because it made me forced to study deeply all of those documents and so on, and make sure that everything was done correctly and things like this.
Right, right. Well, actually, personally, this is I'm very pleased to hear of this focus. Actually, it's kind of weird to call it a focus, but because it's actually pretty broad. But the reason I say that is that for those of us when WebRTC started. Right. One of the things that we knew, of course, that people would use it for telephony replacement. Okay, everybody would have their WebRTC endpoint support and so on. But that's not really why it was created. It was created to try to bring communications to the masses, right? To the masses of JavaScript developers, and make it and allow them to just innovate and come up with something new and different. And yet, many of the gateways, many of the commercial systems that are out there just reproduce the exact same use cases and verticalization, like you're talking about, of all the prior products. And so, so I guess you're really helping the promise of WebRTC here by, yes, enabling those as well for anyone who wants to do them, but not limiting what you provide to that, and actually not limiting the extensibility and making the extensibility for anything beyond that easier.
Yeah, and we have to be happy that eventually there was no agreement on any signaling protocol by itself, because otherwise we might have ended up in the closed set of gateways that you described before. So we would have stuck with any of the existing protocols at the time, and this would have limited the scope of the applications that you could implement.
That's right, and that's exactly why it was done. The lack of standardization on the signaling. Yeah, yeah. So so I'm curious in this. I was going to say sort of this grand vision, but maybe it didn't start so much as a grand vision as just a coding project, and then it turned into a pretty grand vision, I think. So in that process of doing that, were there things that I mean, you mentioned some things that went better than you expected. Like it was actually easier to get some of the parts working than you thought. Were there other things that surprised you with how well they went? I'm next going to ask, of course, which things didn't go well, right? So I want to start with the positive first.
Yeah, no, one of the things that went much better than we expected is not strictly code related, but is actually in the response that we got from the community in general. Because one of the big questions that we had at the time, so before actually releasing Janus, was whether it should be made open source or whether we should keep it as a closed project of some sort. Because
Right.
we knew that we had something on our mind, in our hands, but we didn't know exactly how to bring it to the world, basically. And we ended up deciding to do it open source, even though we were a bit scared at the time. So as a small company, you're always scared that people may come and steal your work without contributing and so on. But this ended up being the best choice that we might ever make, because the basically by making it open source, a lot of people were actually able to play with it by themselves and then providing suggestions, providing feedback. We met a lot of people that started contributing to the project. It really went much better than we initially expected, and it put all the fears that we had about the open source release completely away, because by making it so widely available, many more people than if it had been a closed project were able to test it, to play with it, and then decide whether or not to stick to it for some reason, which also helped with the bugging. People were testing it, finding bugs much sooner than we might have done by ourselves and so on. So this is definitely one of the things that I actually was very happy about with the outcome of Janus itself. And then of course also the, as you said, the general purpose of the nature of Janus actually expanded to a point that it actually went beyond our own ideas, because of course we had our own use cases in mind, which ended up in the plugins that we implemented out of the box. But then people started contacting us with even crazier ideas that eventually turned out to be possible with Janus. For instance, there was a demo that was made at the very beginning of Janus by a couple of very known people in the WebRTC world that used a drone that you could control via Janus, via data channels, and won a demo with it and so on. And that was something that really blew my mind away, because it showed that actually we had done something that could be used in crazy ways that were outside of our control or our ideas and so on. But yeah, as you said, it's not always just roses and so on. There's also the downside of that. And I think the main downside might be that not everything turned out exactly the way that I conceived it at the beginning, because for instance, the modular nature that I had in mind for Janus at the very beginning was even more ambitious than it is right now. So it is quite flexible, but I really had in mind something that was even more complex, that allowed more of some kind of a GStreamer-based approach, where you have stuff like plugins that act as filters, as sync sources, and so on. But this never turned out to be the case, and it's probably good that it didn't, because otherwise Janus may be still under development, and I might and so on. And there are things that are still missing in the specification that I really care about, like the multi-stream support and so on. For lack of time, I never find the right occasion to start actually focusing on that aspect and so on. And so there are some things that I still wish I had more time to work on. But in principle, I'm pretty happy with how the book came out.
So my audio cut out just slightly, just when you said that one thing, that is when you actually said that, and I heard multi blah, blah, blah. So could you just say again what it
Okay.
was? Yeah.
Yeah, no, I was mentioning the multi-stream support. So the idea that with the WebRTC connection, you can actually aggregate multiple streams of the same type over the same peer connection. So you can have one outgoing audio, one outgoing video, and 10 incoming video streams, for instance. And this is something that by design currently we do not support in Janus. So you can only have, in a single peer connection, you can only have at max one audio, one video, and one data channel. And this is basically all you can do with a single peer connection in Janus, which means that if you want to do some kind of an SFU, you will need to involve multiple peer connections in the process to implement the kind of bidirectional communication that would be needed. And of course, having multi-stream would help in several scenarios. It wouldn't help in all the scenarios, because the plugins are still isolated from each other. So you cannot have, let's say, a single peer connections where some bits go to a plugin and other bits go to another plugin. So you would still need to have different peer connections to talk to different plugins. But the ability to aggregate the streams of of the same user with the same plugin into a single pair connection would actually give some benefit. And this is something that is definitely on our mind, and we want to implement it, even though, of course, there is the problem between the lack of agreement between browsers on how to do this right now, like the plan B versus unified plan and so on, which would make this even harder to handle. But again, this doesn't mean that we shouldn't actually start working on this as soon as possible.
Sure. And that I think there actually is still agreement on how it's supposed to work. They just haven't implemented it yet. Yeah,
Yeah, I didn't want to say that, but yeah.
yeah, I know. um, yeah. So we're both very aware of what's happening in the standards world and the really good progress there, but the implementations are a little bit behind right now and in the browsers, and I think that's going to catch up. There are good commitments there for that to happen. So you talked a little bit about the reception that you've gotten for Janus, and that it's actually been really good. So I'm wondering, do you have anything else you'd like to say about that? Is there, you've mentioned a couple interesting use cases that people had, but have you, what have you encountered in terms of people saying, yeah, this is what I needed and this is why, right? I couldn't do this other thing until I found Janus.
Yeah, most of the times it's people contacting us saying that they did their homework, they tried to have a look at the existing solutions, and eventually they chose Janus because it gave them the right flexibility to do their things. So often we are not part of that decision process, which in part is a good thing, because the availability of so many open source solutions out there actually, I think, helps the whole WebRTC server ecosystem in principle, because it allows people to actually, again, do their homework. So study what's available, study how they all work, experiment with them, and so on. And so knowing that so many people actually eventually end up using Janus for their needs is actually something that makes us very proud, because it means that actually people try to do things with other solutions. And of course, not because the other solutions are bad and so on, but just because they may be too focused on one specific scenario, they end up preferring a solution like ours instead.
Sure.
So,
I'm curious, is there anything that you would recommend that people not consider Janus for? That, like, you just say it's just not the right tool. I mean, you could use it, but you shouldn't.
yeah, that's a good question. That I really don't have an exact scenario in mind. I mean, there are some cases, some people contact us thinking that Janus is just a pure gateway. So, for instance, they come up with the idea that, for instance, the SIP plugin is some kind of a SIP gateway, SIP server functionality by itself, and so on. While instead, I'm just making a very specific example here, just to give you an idea of the reasoning. But sometimes they have a different assumption of what actually sits between the Janus plugins by themselves. So, for instance, the SIP plugin itself, which is the plugin that allows you to implement the SIP gateway functionality, so allowing you to do WebRTC to SIP and SIP to WebRTC scenarios, is actually just a very simple WebRTC enabler for SIP calls. So there is a SIP stack that sits within the plugin, but only acts as an endpoint. So it doesn't act as a SIP server or a SIP proxy or something like this. It's just an endpoint that you can use on behalf of users in order to register at the SIP infrastructure, send calls, receive calls, handle the process, just as if it were a regular SIP token and so on. So anytime that you end up wanting to do more crazy things with this, like creating complex infrastructure based on SIP within the SIP plugin itself, this is something that I discourage, because I say this is something that you can do with existing SIP infrastructures already. So if the access is what you need, then Janus can help you allowing these users to communicate with the SIP infrastructure. But don't ask Janus to do more than it actually needs. And this can be generalized to basically try not to reinvent the wheel as much as possible. So if there are existing solutions that work well, so one thing that we're asked often is, can Janus do transcoding? We often say it might, so you can implement it in your plugins, but we discourage it. So try and keep Janus as lightweight as possible. Make sure that the streams go where they need to go. And if you need transcoding, make use of the several existing solutions that allow you to do that much better than we could if we had to implement it on our own. So in principle, I suggest to try not to reinvent the wheel and try to use Janus in conjunction with other applications that may actually help you do the job, because there are many and they are actually very good.
That makes sense. So a plugin is supposed to be a plugin, not a.
A full-fledged application,
Yeah,
yeah.
exactly. Right, right, right. So I'm curious in this process, like the process that you've gone through of building this. What have you learned during that process? And one of the reasons I'm asking is that if there's someone else who says, hey, maybe I'll just build my own thing, just like Lorenzo did, well, is there any advice you would have for them? Something you're like, yeah, don't do this, right? Because that's a bad idea.
Yeah, no, the first suggestion is definitely do your homework, because especially in the WebRTC world, I mean, we've all shown that huge slide with all the WebRTC protocols and technologies that you need to be aware of in order to implement the WebRTC stack. So you really need to do your studying, and that actually was very helpful for me at the time, because I really had to delve really deep into all the documents in order to understand how exactly everything worked. And sometimes that isn't even enough, because then you start to clash with what's supposed to work and then doesn't because of other reasons and so on. You start to become an expert on debugging issues and things like this.
Right.
But in my experience, Janus was really a great learning process by itself, because I had implemented a lot of stuff since then, since the very beginning and so on, but really never something that was so complex at the time. So even the modular architecture and so on, it was something that I was mostly familiar with, because I had worked a lot with Asterisk. I still do from time to time. I had worked a lot on the media control specification, which was in principle modular, as we have explained before, and we also implemented a prototype of that server. So I had already a bit of familiarity with how to do that. But really, making it as modular as Janus is proved to be a quite helpful learning experience. And one thing that I suggest is to try to make your application as modular as possible from the very beginning, which is something that, to my fault, I didn't do from the very beginning. So I had made the plugins themselves, so the media plugins themselves, modular, but I hadn't done the same for other things that I could have done within Janus, like transports, for instance. So at the time that Janus was released, we only had a simple HTTP-based interface API that you could use to talk to Janus, which from an API perspective is exactly the same as it is today. But how it was implemented was completely different. So it was hard-coded within the code and so on. And so as soon as people started to come up with ideas like, but why don't we use WebSockets? Why don't we use RabbitMQ? Why don't we use foo or bar or whatever? As soon as we wanted to make this possible, it would either have meant let's add a lot of stuff to the core and make it as heavy as it can be, or let's try and make these other bits modular as well, which is the road that we took. So this is what we did eventually, but it took a bit of effort, a bit of time and so on, that we could have spared if we had thought about that at the very beginning and so on. So one of the things that I can definitely suggest is try to think about all the responsibilities that you can separate, all the things that you can actually put in modules and make modular and expand later on, and try to do that yourself as well, because it's going to pay in the future.
Right. Right. Yeah. That makes a lot of sense. And I can see, sometimes it's hard to have the full grand vision, when you start, for just how modular to make something. And sometimes you're just trying to get it to work too, I imagine,
Yeah.
So
yeah, no, absolutely. In fact, the first experiments that I made were all very hard-coded. So I had a simple WebRTC stack. I was sending my streams, my RTP packets from within the same code and so on. It was really ugly and so on. The first experiments, just to see if I could get things working, you don't want to see those. But as soon as you have a better understanding of how you can separate all of those things, it eventually pays up along the road, because you end up being able to do a lot of things that you were not thinking at the time when you actually started writing the application, which proves to be really helpful later on.
Sure. So what's next? Is there anything that you're excited about, or that you think needs addressing? You talked about multi-stream, obviously, but is there anything else that's kind of like, ooh, man, I'd really love to do this?
Yeah, no, there are a couple of things. One is a thing that I'm actually working on right now, that is a new plugin that we've started implementing, and we've actually also released it as a pull request at the moment, which is a Janus Lua plugin, because so far we basically discussed in general that Janus is a modular architecture. You can write your own plugin and this and that.
Right.
But of course, Janus is written in C. So if you want to write your own plugin, ideally you need to be competent in C. You need to know how to write your own plugin in C, which can be complex for some people. So, and it is what led us to actually start writing a new plugin that can actually act as an intermediary between a Lua script and the C code. So you have a C plugin that takes care of all the, let's say, low-level functionality that most of the plugins use. So how you can actually make sure that one stream gets to another destination, so that one stream coming from a user gets to another user. So this kind of media routing, or let's say sending a keyframe request, or handling the life cycle of a specific user and so on. So these are all things, the low-level stuff is all done in C, and then we expose all the functionality itself via Lua script instead, which means that you can write your own Lua script in order to decide which kind of application that you want to implement. And just for fun, we implemented like an echo test clone written just in Lua. We implemented a simple SFU written in Lua itself. I implemented a demo that does some kind of a chat roulette written in Lua. So everything without touching the C code, we just play with the Lua script in order to decide what to do with the media coming from the user and so on, and without ever touching the media either. So you just invoke some methods and so on.
Right.
And this is something that's going to be really, really exciting. And so it might be the next step in making these even more modular in the future, because then you can have your own battery of Lua scripts that just fits whatever use case you have in mind and so on. And apart from this, one of the things that I also want to really push forward is the scaling of Janus instances by themselves. Because right now, the concept of scaling is, let's say, mostly, let's say, a loose orchestration of the Janus resources that you have, mostly because each Janus instance is pretty much an isolated component. And so two Janus servers do not talk to each other, and probably neither would I want them to actually talk to each other and keep some state. I want them to be as unaware as possible of each other and keep all the state in a controlling application of some sort. But making these actually more dynamic, flexible, and so on is one of the next things that we want to start working on. So that if you wanted, you could implement some kind of if you allow me the term, some kind of a platform as a service kind of thing that is actually based on Janus as the bricks in the background, so that you can say, I need a conference with 1,000 users. How do I do that? So how you can actually distribute multiple Janus instances in the background and make these transparent to the user actually using these resources in the background.
Okay.
So, and aware of the fact that maybe streams that are actually redirected between each of them and so on somehow. So this is something that we really would like to start working on, because this is the next step. Because of course there is only so much optimization that you can do on the single instance by itself, and say you can scale a single Janus instance up to X. If I want to do X plus 1 million, how do I do that, basically? And this is the answer that you're trying to find.
That's interesting, because I heard you talking about essentially it's not just efficiencies, but what happens as you scale. Is there extra stuff that you can do to make the life easier for the users, basically, of it? Without them having to explicitly code how those different instances would interact. It sounds so it's not just scaling up. A lot of times, scaling up just means, oh yeah, now you can ask for 10,000, and your machine doesn't explode because we're efficient in the use of resources. But I thought I heard you talking even more intelligently than that. It's not just about efficiency. It's also perhaps about ease of use, ease of working with that larger number.
Yeah, exactly. And the problem there is also that there are only that many assumptions that you can make with Janus itself, because scaling a Janus-based application may be done in a specific way, and the same approach may not work with another Janus application instead. Because the different nature of the plugins means that each plugin may actually scale in a very different way. So the C plugin just acts as a zip endpoint by itself, so there is no interrelationship between any of the zip codes that it does. So if two users are actually talking to each other, that's a problem of the zip infrastructure in the background. But from the plugin perspective, it's just handling a user, turning it from WebRTC to zip or vice versa, and it's done. So you can handling 1,000 calls or 10,000 calls or whatever it means, and you can just spawn as many instances as you want, and then just let's say load balance the usage and say, okay, I'll put this user here, this user there, and so on. As soon as there is some kind of an interrelationship involved, instead, like it may be with some kind of a video conference or an SFU or something like this, where you have a one-to-many kind of approach, where the one is actually the shared source of information for all the many that are actually receiving this packet, this becomes more complicated, because in that case, you cannot just say, go on server 1 if the user is publishing on server 3 without doing anything that actually makes those packets go from server 3 to server 1, just to make a very simple example. Right. And it becomes even more complicated when you try to involve different plugins and so on. So context awareness is very important when you do scaling, and making these, let's say, less of a problem for the user to worry about, for the application to worry about, the better. So if you can find a way to make this pretty much automatic without you having to worry about how the context actually works and how to distribute this in an efficient way, is problematic, which also incidentally made our own scaling tests complicated, because of course each plugin needed to have its own stress campaign that was addressed in different ways. So saying it can serve 1,000 peer connections may be true for one plugin and may not be true for another plugin. Right. The concept of users is different, because a user can be associated with 10 peer connections rather than one. The bitrate may differ from use case to use case. So, I mean, the flexibility is a plus, but it can be a it can be a nice problem to have to face later on.
Sure, sure. I mean, now you may end up having to classify plugins in certain ways, or require them to provide certain kinds of interfaces in order to benefit from the what you're talking about, basically the intelligence that you can add in there. I presume that you don't intend to create an arbitrary program writing program that has computer science concerns, right?
No, I mean, yeah, the idea is to implement some kind of an orchestrator that implements the context awareness in there, because there are, let's say, some common properties that one can evince from the relationships between all of these plugins, and so that's the idea in principle. But yeah, not something that's as complex as you were suggesting.
Right, the arbitrary Turing machine thing. Yeah, right. Okay.
No, absolutely not.
Yeah. So actually, I have one follow-up question on something that you had mentioned. I'm a big fan of scripting access. I have in other domains. So my background is speech recognition, and one of the best things we did in our research lab was actually we were using Tickle at the time. Okay, that was one of the languages that was available and easy to extend with TCL. And so we did that actually for our recognizer. We actually broke all the pieces up into and then gave script access to each of those pieces. And for doing research, it was just phenomenal. It was really, really unparalleled, because you weren't constantly writing and debugging your C programs. It was much faster to do scripting. So I'm a big fan of that. I'm curious, why did you choose Lua? I have nothing against it. I'm just curious.
Let's say,
yeah.
Yeah, no. I mean, it was actually, it was suggested us by one of the companies that we are doing consulting for, and so it was a bit of a, let's say, this is something that we might both benefit from. So they were more proficient in Lua at the time, and we wanted to have something that was flexible at the same time. But the idea is that these Lua plugins should actually just be a door opener, so not the only solution for that. So, for instance, as soon as I started mentioning this effort with the community and so on, I chatted with Sauli Barracoregge, which I don't know if you know, is a very nice guy who he contributed a lot to Janus in the past. Now he's working on Jitsi, and we're very good friends, and so we were discussing about this new functionality, and also suggested why not doing the same with JavaScript, for instance, which is something that a lot of people use, and he suggested a project that might be able to help with that. And for instance, now I'm talking with you about this, and this other idea came about, and so ideally, these are all this is all feedback that actually might end up in Janus sooner or later. So as soon as the Janus Lua plugin is up, let's say up to a point where it can actually be used in an efficient way to implement what it needs to do, right, the same exact kind of binding functionality can also be abstracted and reused in other contexts as well, because all the low-level stuff is already there. So all the media routing and stuff like this.
Right.
all you need to do is hooking this up to a different language, so it's like to JavaScript or to the technology that you're mentioning, or
Right.
to Python or whatever one has in mind. So um, really, this is exciting for us just because it allows us to go beyond the idea that if you want to write a plugin in Janus, you need to do C. The idea is to
Yeah.
say you really don't, you can do it in other ways and so on if you're creative enough. And for instance, I'm aware of another company that has done a Java binding to plugins instead. So they are doing all the logic in Java, and they have some kind of a Java access,
Right.
Java native access kind of bridge that actually allows them to do that. So I'm really curious to see where this all will lead.
Yeah, you could argue whether or not that's actually faster than writing in C, but
Yeah, that's true.
but plenty of people have Java frameworks, and it's really nice if they can just operate in that world. So I guess the last question I have is there anything else that you'd like to tell us? Anything you know i in the works, or an announcement that you're excited about, or anything you want to talk about?
Yeah, I mean, I think we covered pretty much all the exciting stuff. I mean, one thing that I'm really excited about is that, of course, we are going to Singapore in a few weeks. I think actually it's next week, so it's actually much
It's
closer than I
very soon.
expected.
Yes.
So we are going to the ITF, where we are going to do the remote participation services for the ITF as usual. So some people may not be aware of the fact that we are actually the official remote participation service for the ITF meetings. So anytime that you
Right.
want to access a meeting remotely or present from home instead because you couldn't make it, you're actually using our technology. And behind the curtains, you're actually using Janus to do that, actually using 3 different plugins at the same time. But that's a matter that we can discuss some other time. I mean, there's
Cool.
a lot to say about that. And after the ITF, we're actually also going on a tour later on to South Korea and Japan as well, in order to talk a bit about Janus and other cool things WebRTC related around. So that makes for exciting times that I'm really looking forward to.
Great, great. Thank you so much. And I look forward to talking with you again. Have fun in Asia.
Okay, thank you.
All
It was
right.
nice to talk to you as well.
All right. Bye.
Bye.